Hello and welcome everyone. Thank you for joining us today. My name is Patrick Moran and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Eric Goodgen is a Senior Principal Solutions Architect at H2O.ai. He is passionate about performance and scalability, and Eric's role enables him to help customers adopt H2O within their enterprises. Now, before I hand it over to Eric, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be available after the presentation is over. Without further ado, I'd like to hand it over to Eric.
Great, thank you, Patrick. And hello, everyone, and thank you for joining today. So today I'm going to talk about using databases with driverless AI, both from a training point of view, where we create the model, and then actually using it in production. So just a little bit about H2O. You're probably familiar with us, having been founded in 2012. We have offices in a number of places, a number of major cities around the world now, and we've been growing extensively. If you look at some of our global customers, you know, some of these customers are well-known brands and cover a number of different verticals within the marketplace. One of the things I just wanted to mention while we're on this slide is, you know, we do have H2O World coming up in New York, where I'm based. So in October, there'll be a lot of events for H2O. And if you're in New York or based in New York, it'd be great to see you. So log on to our website and register for the event. So let's start talking about databases. You know, databases are typically the system of record for most organizations. And we want to be able to use that data because it's so rich and describes our customer base in all sorts of different ways, from their behavior, the transactions they do, you know, demographics about the customer. We can use this to actually build models that are really valuable to the organization. So to start doing that, in driverless AI, in version 1.7.1, we actually created an adapter that allows us to connect to JDBC databases. So it's a Java connector that driverless can use in order to connect to a data source, extract some data, and build a model on it. And we'll look at how to do that. The next thing after we've built our model is actually scoring data in real time. And with a database, we probably want to do that as a batch operation. So we'll show you a couple of different ways to do that. One in Java, which is a really highly scalable approach to doing this. And then also using Python. We'll show you how to use that as well, because that's a very common language that a lot of the data scientists are familiar with. The one I'm going to spend some time on with the scorer is using the Mojo. So that's the model object optimized that driverless produces. And this allows us to also take this Mojo and use it within things like Hive or within different applications directly. It's a very highly portable, very efficient way to score in real time. One of the last pieces I'll cover is using driverless AI recipes. Now, if you've been following driverless evolution over the last few releases, you'll have seen that we introduced something called recipes. And what this allows organizations to do is to describe their knowledge about the data, about their business, their domain expertise, if you like, in a recipe, which is basically some Python classes that override the behavior of driverless. What this allows you to do is then take those recipes, use them within our feature creation, our MLI interpretability, and then also in scoring. And so we'll look at how you do that, particularly in the Python piece. So let's start by looking at how we go about creating the connection to the database. So the first thing we want to look at is, you know, defining the JDBC driver, and we do that through the driverless config toml file. or by using environment variables. If you're using Docker, it would be a convenient way to use the environment variables. So the configuration itself, I actually have down at the bottom of the screen there. Yeah, I have two examples, a connection to a Postgres database and one to Microsoft SQL. You can see I define in the URL key, I define the JDBC connection string. So your database administrator is probably really familiar with that syntax, and it's going to be slightly different depending on the database you connect to, but they're pretty standard and really easy to find. Most database vendors have a JDBC driver, and they publish, how to connect to them. The thing that we want to do is pass, where it has jar path, the Java class, the Java file that encapsulates the driver for this database connection. And so that'll be a unique file name for each vendor. As you can see, I have one there for Postgres and one there for SQL Server. And then we need the name of the driver itself. So this is the class name of the driver. And usually when they publish the file, they tell you what the file name is. It's fairly easy to find. So that's really straightforward to set up either in the config.toml. In fact, there's an example in that file if you look for it, or using that environment variable. But the thing to remember that does catch people sometimes is that we have a configuration setting called enabled file systems. And that basically describes what file systems and the connectors that are enabled for this driverless AI instance. You want to make sure you add JDBC to that list. Usually it's things like, file, HDFS, things like that. You just want to make sure JDBC is on there, otherwise you won't see the option. Once you restart driverless, that configuration will be picked up. And when you log into driverless and go to the datasets panel, you'll notice that at the very bottom of our screen there on the left-hand side is JDBC. And if I click on JDBC, I'll get a list, as shown here on the right, the different JDBC connections that I have configured on my instance. In my instance, I've actually configured a couple of different Postgres databases, the Microsoft SQL database, my Oracle database, a DB2, and MySQL. And literally anything that can take a JDBC connection, you could put into here. I select the connection that I want to use to get to my data source, and then a panel will appear that will enable me to complete just a couple of runtime things that the system needs to know. So the first one, being there on the right-hand side, is the username and password. Many data sources, particularly databases, use access rights to determine what you can see and what you can access in the database. So we need to be able to pass that to the server so that all the security is still in play. Destination name is the name that the data will appear in the driverless AI system. So you can mark it as something that's meaningful, maybe monthly sales, and it will appear in the system. And then at the bottom of the screen there, the JDBC query, this is literally the select statement. So I'm going to type in select, asterisk, or my column names from, and my table name. And then I click the query button, and the data will be imported into driverless. I'm not going to run through building an experiment. There's a whole bunch of talks on doing that. In fact, you can even come on in October to our event, and we can actually show you one as well. But there's lots of events, lots of videos on doing that, so I'll skip that. But what we're looking at here now is what happens at the end of the experiment. This is where we want to start consuming this model, and this is the piece where we want to put it into production. We want to do some testing on it. We want to actually maybe use it as a batch job to score massive amounts of data. At the end of the experiment, you can see it highlighted there in white is the option to download the Mojo scoring pipeline. And what we want to do is click on that, and it will download a file called mojo.zip. You'll see the screen pop up there on the very right. It says, if it's the Java option, there's an example pipeline that you can use. There's also a Python and R version, which is the runtime that uses the Mojo, but for Python and R, written in C. One of the things that customers quite often will do in a production environment is they will use the driverless event notification to automate taking the Mojo and pushing it to their deployment pipeline. Maybe they put it into Jenkins or GitHub or Bitbucket, and that automates the entire deployment pipeline for them. If you're interested in that, let us know. I can help you set that up. The end result here is we've taken the pipeline.mojo file because that is the piece that we will use for scoring. And so when we go to score, we're going to look at two different options, as I mentioned. The first one is to run the database scorer we call DAI Mojo Runner DB. And what it allows us to do is to connect to any JDBC data source, any database source, and read a row of data, and then score that, and ultimately write it back to the database, to a different table, or output it as a CSV file. The idea here is that we have ways to actually make this highly scalable, right? So I've seen customers using this that are doing, tens of thousands of rows a second on, fairly low-end hardware. So it's very scalable, very performant. For the scorer, you need to have the JDBC driver, just like we did when we set it up inside of driverless to build the experiment. So this is pretty straightforward. We're going to have the same driver, we're going to have a very similar configuration, and we're going to look at how to do that. We've used the scorer with all sorts of different databases, things like Redshift, Postgres, SQL Server, Oracle, Teradata, basically anything that has a JDBC driver, a Type 4 driver, which is almost all of them, would work with the scoring side of this. So when we look at the score itself, the program that we provide, this runner, what does it really do? So you can think of the larger rectangle as the program itself, and then internally what's going on with this program. So starting on the very left-hand side, we have the database, and we have a SQL select that reads rows that match our select statement into our program and puts them onto a task queue. The task queue is a single row of data that's come back from the database. We then have a number of CPU threads that execute a copy of the pipeline itself, the Mojo pipeline. And remember, this pipeline that's coming out of driverless contains both the transformations that occurred as we did our feature engineering and the scoring prediction as well. So we don't have to do any additional work. Each of those CPU threads reads a single row from the task queue, runs through the pipeline Mojo, and then looks at how you want the results stored, either pushed back to a database or pushed back to a new table as an insert, or written out as a CSV file. So we can scale this in a number of different ways, you might imagine. We can define the number of CPU threads that we're going to run. We can write it out as a set of CSV statements that maybe you do a bulk upload later on. You have a number of different options in how you want to scale it. Now, when we define this program, we have a properties file, and this properties file helps define the runtime characteristics for this model. So the actual parameters in the property file are in the yellow bubbles, and it helps define each of these steps that I just described. So the SQL connect string defines our data source, just in the same way that we did in driverless AI when we added it to the config.toml. It's the JDBC connection, it's the host name, it's the port ID, the port number rather. We then have our SQL select statement, and this is going to select the data we want to score from the database. This could have a join, it could be a complex SQL statement. As long as it's a valid SQL statement, it will get executed and the results will get pulled back. The task queue is actually defined by an option called capacity. And that's basically, we use that as a way to write to the queue to fill as many CPU threads as we can. And so you can have a capacity that, it's automatically configured, but you can override it. You can also override threads. By default, what the scorer will do is it will use the number of available CPUs that are reported to the Java process. But you can override that if you need to. Typically, I find once you go past, 2x the number of cores, you're not going to get any more benefit. You're going to start context switching too much. The pipeline.mojo is defined by the parameter model name. And we do that because you probably are going to not use our default name of pipeline.mojo. You might call it, monthly sales.mojo or, customer predictions Mojo. Then the final output is how you want us to handle the predictions once they're made. So SQL write handles the update to the existing row, how to do an insert to a new table, or if you want the data just written as a CSV. The interesting thing here to actually use, which you don't technically have to use, but it's much more efficient if you do, is the SQL key. And that is the index key to the database table. If you don't pass the key, the database will actually end up scanning the table for a match, right? So it's more efficient to pass the key. So here's an example property file already defined with those parameters. And so what I quite often will do is I will create a property file for each of my models. And that's because the model has some unique things like the database is going to connect to, maybe a different one in production or a different one in test. And the SQL might be different depending on the model that I'm running. So I can have multiple property files and just pass that to the program. You can see the SQL connection string is identical to how we defined it in driverless. And then the user and password that we use, the password is encrypted, so that can be hidden. The SQL key is the ID that the table in the database is indexed by, and your DBA will know that to help out. It will just be much more efficient. And then we have the SQL prediction. Now, this is actually quite handy. As you know, when you score a model, you'll get back, a target.0, target.1, or maybe multiple results being returned. If the prediction is blank, as it is here, all the targets that were returned will be written to the database. But if you only wanted, target 0, for example, then what you could actually do is just say prediction equals 0, and the program will just take prediction 0 and write that out. It's basically the index to the prediction. Now you can see in the SQL select, I have my select statement, I have my ID, which is my index, and then a number of different columns that I'm picking out from that table to actually be built. So that's one thing that you need to look at and define, and that can be a little tricky. So we have a neat little way to actually help build that SQL, and the same with the update statement at the end there. So the write is our update statement. It's going to go back to the same table, and it's going to set the target variable columns to the output that was received from the model. But how do we create these select statements? Because they can be quite long. So there's an option in the program that we pass called -d inspect equals true. You can see the command line there on the second line. What this will do for us is a couple of things that's kind of useful. It'll describe the model to us, so we get this, our unique UUID. So if you're putting this into a model management system or some framework to track the life cycle of this model, there's a unique number. We describe the input features, so the name and the type that value is. So you can see float 32, the term is a string, and the output features. These are our targets. So you can see that they've been written out as type, float 64. Now this is the target variable that's going to have to exist in that column, right? So if I'm going to write back both bad loan 0 and bad loan 1, then in my database table, I need to have a column called bad loan 0 and bad loan 1, and they both need to be of a type float 64. They can be strings as well, but we'll be giving you a float 64. You can put it into a string automatically. The database will handle that. But how do we generate the SQL? So the other part of the output of the inspect is to actually write the SQL statement for you. So you can see here on the second line, I can generate the select with the correct columns that are going to be used to read from the data source. All you need to do is change the things that say add your table index and add your table name at the end, beginning and the end. That's because I don't know, there's not an easy way for me to really figure out from the model what the table index is, or actually what table name it really is. So this actually is generated from the model itself. So a DevOps team might use this to validate the correct property file or the correct Mojo file name, as well as just helping to make sure there's no typos along the way. So it generates that both for the select and the update. And then the other thing that's kind of useful is that if you ran this on the system where you're going to do the scoring, it tells you how much memory is on the box and what some of the Java options should be, right? So on my machine, I had 16 gig. The program was taking about 9 gig when it was running. And I shouldn't use more than 12 gig by setting the MS, which is the minimum memory and the maximum memory size. And it tells me how many threads are there, right? So it's got 8 CPUs, 8 CPU threads on this machine. So I'll be scoring 8 rows concurrently. So it's completely concurrent on 8. That'll be the default behavior. So the interesting thing here in use cases for the property file, and I mentioned a couple of these before, was different database environments, different tables you want to handle. Maybe you don't want to update the original record of the customer. Maybe you want it to go to a new table, maybe like customer results, customer.results or something. That allows you to actually control all this behavior through the property file. Now, by default, the program looks for a file called DAI Mojo Runner DB properties, but you can override that by passing the -d option on the command line and use that file instead. This allows you to have multiple files, multiple Mojos, but one program. So how does it look when it runs? So in order to run, your scoring on a separate server, you need a valid driverless license file, and you can pass that license file either using environment variables, or you can actually pass it as an option on the class path on the Java command. I usually set an environment variable, so it's really straightforward. In fact, if you run the command without setting the license, the output will actually tell you how to go about and set the license. It will actually give you the options that you have. You need a JVM, Java 1.8 JVM, and you need to have the JDBC driver that you're going to use to connect to the database. So we can see on the next line is actually the Java command that I'm going to use. So I'm going to set my Java heap to 10 gig. I have the Postgres SQL JDBC driver in my class path. I have my program, and I'm going to go and invoke the program. So what actually happens, if we just walk through this pictorial of it, on the very left-hand side, I have a set of IDs. These are the unique key, and the ID is what I'm using in the table as my index. And you can see both bad loan 0 and 1 predictions are blank. I run the command. You can see the transactions spike actually pretty well, sort of over the 1,500 transactions a second. And in a very short period of time, I've scored about 32,000 rows on my database. And you can see on the very right-hand side, the data is now populated on those tables. There's a few things that we want to do along the way. We want to look for were there errors that occurred in scoring, if there are any timings, that type of thing. So just to finish off the runtime piece, if I wanted to pass a property file, there's that example, right? So I'd say -d properties file, monthly sales, exactly the same, command line syntax. Just one change points me to a new model, potentially a new database, and you're good to go. So when we output the data after the end of the prediction, there are a few different options, as we mentioned. Updating the table, inserting, writing the CSV. So how does this look? If we pass an option that says save equals true, what we do is we write out the SQL statements that the program generated, but we don't update the database. And we do that because there are, some databases prefer having bulk uploads done, not small updates done. And so this gives you the ability to actually take them and then do bulk inserts as a batch operation. So you can see here as an example, the program was actually saving the insert into a new table. So it was a brand new results table, and it was going to pass that data directly in. Save, set the SQL write to CSV, then what will happen is the standard out will have the feature names, and then each row of data with the prediction written out. And you can see the example here for the same row of data. Right, we've got the ID, prediction 0, prediction 1. And then, as I mentioned in the beginning, one of the options is, sometimes you don't want all the predictions. You just want the 0, prediction 0, because that's the only one you really might worry about. So you're able to pick if there's a specific prediction you want by setting the SQL prediction to that offset. And in this particular case, I actually saved the output so you can see really what it does, right? It actually sets the bad loan variable to the value, and I still write the key out in that prediction. Now, sometimes you have, hundreds of millions of rows, and you want to go as fast as you can. So there are a few ways to do this. With the scorer, what you can do is you can have multiple scorers running using slightly different select statements, so you can get as many separate physical machines scoring against the database in one go. And so in this in this picture, what we see is we see server 1 and server 2, and they're both running the same pipeline.mojo. The only difference is that the property file has a slightly different select statement. The way this looks is that in the property file, the SQL statement has an order by and an offset and row fetch size. So you can see here in the first one, what we're doing is we're ordering by the ID, which is our key, and we're starting at row 1 and we're fetching 100,000 rows. And then in the second instance, the second server, we're fetching from row 100,001 for the next 100,000. What that allows us to do is then score, reduce the elapsed time for the entire scoring as much as we can. And of course, the more instances we add, we change these offsets, but the faster you can go. And you can do this until you get to near saturation point on the database, right? The database will end up being we'll have some row level locking, so there shouldn't be too much contention. But at some point, there's going to be a bottleneck, and we want to try and get as close to that pressure point on the database as we can. Now, each database vendor will have a slightly different syntax for the order by and offset, but most of them have a variation of this that allow them to split the selects in this way. So a few things to remember when you do this. Some transactional databases, don't like mass updates, and so to cope with those types of databases that are very fast at reads but slower at writes, consider using the CSV file and then using that database vendor's bulk upload tool. If they prefer mass updates, they'll have some bulk upload, bulk update tool. So have us write the CSV and pass it to that tool. The other option is to actually write out the SQL statements using that save option. And that gives you the ability in your DBA, the ability to look to see if there's a way to batch them together. Always remember to use the SQL key because otherwise the database will scan the table for the updates and the inserts, and that can be very inefficient. There is an option as well if you want to keep an eye on how many rows were selected and scored on. If you say -d stats equals true, then at the end, what will happen is that we will write out how many rows were selected from the database on that select statement. And then on the threads that we were running, each thread will report, each CPU thread will report how many rows it processed or read, how many it processed, and if there are any errors. So why would there be errors? The data that comes back from the select has to match what the model was built for, right? So if there's missing values and you didn't handle the missing value in the select, or there was some transformation type error, then that gets counted as an error, and the stats will reflect that as well. Now, if you wanted to see the errors, so you could see what was going on, you can actually pass errors equals true, and what will happen is when that, one of those 29 in this case, errors occurred, we write out a line that says, hey, this is the reason why. In this case, there were too few features, right? The select didn't actually return some data. There were some missing values in the data. The way that the scorer is built, its default behavior is that it assumes the data is just the way it was given to us when we trained it. You can, of course, handle this in SQL. You can tell SQL to, if there's no value, to actually set the value. So we leave that as a decision to be done on the SQL side rather than the scorer. So that's the Mojo side of using that from from driverless and using the standalone scoring program. Now, the other way, of course, is to use this using Python. The Python piece is actually really straightforward to go ahead and do. If you created your own recipe, as I mentioned earlier, you could use the scoring approach to include that recipe as part of the scorer. So let's have a look at this. The reason you do this is that the Mojo might not be available because the type of model that you've created. And if you're going to use Python, then you've got to have the correct Python environment, and you've got to have a Linux x86 environment to execute on. You're able to actually go ahead and use the existing pipeline that we generate from driverless as an example. Okay, so it's a very small change that you need to make to the example.py that you'll find in the scoring pipeline. So I've summarized those changes, and we'll look at one in real time as well. So in the scoring pipeline itself, when you open up that scoring zip file, you'll find .py, and we're going to look at one, but I just want to highlight the differences here just quickly. So what I'm doing is I'm scoring against a Postgres database that's remote to my server. So I'm going to import the Postgres library for Python, which is on line 1. I still set a scorer object, which is what we do anyway in the code, and I create predictions from that scorer. You can see on line 3, I have some data that is being created and the different features, and on line 4, I'm just printing my prediction. Nothing terribly exciting. Now on line 5, in your actual code, you might cache this differently so you don't create a connection each time, but I want to create a connection that connects to the remote data source. And so you can see I have my JDBC connection statement to my host. I create a cursor, which is basically where I'm starting at the in the database on line 6, and I execute on line 7 my update SQL statement to update the bad loan 0, and then I print the number of rows that were affected on line 8. I commit the change, I close the cursor, and I close the connection. So that's really straightforward to look at, and let's look at how this actually looks. So you should be able to see here my JDBC connection. If I just run that Python, what will happen now is that builds the object, connects to the database, makes the prediction of 0.9, 90%. I had one row that was affected, and I closed the connection to the data source. If I look at the code for that quickly, if I look at the code for that, then this is the code that we give you anyway in the scoring pipeline. All I end up doing is adding in these lines after I've got my prediction back, which you will see in the scoring pipeline anyway, and I save it away with my cursor at my current cursor position. It's a really easy way to make that run in Python. Of course, this is single-threaded, right? So you want to do all these pieces, initialize them early, and then just basically only commit later on once you've got a number of updates completed. Now, if I want to run the one for the Java piece, you can see here I've got my connection to, and this was the number of transactions per second that were hit by the Python score. Now, if I just go ahead and run the one for out the output here, so you can sort of see it run. And you can sort of see, pretty much we're, just past 380 transactions a second. And this is on this is on my laptop, right? So, for my poor old laptop that's streaming live as well as running the score in real time with, I think I had 10 threads, it's doing pretty well. So that gives you, an idea of how some of these things execute, different ways in which you can take them into production and score on them, and different languages that you might use, whether it's Python or Java. So at this point, I'll pause. I'll thank everyone for their attention, and if there are any questions, I'm happy to answer them.
Thank you, Eric. Yes, we actually do have a few questions. The first one is, do the model predictions need to be saved back to the same table?
Yes, that's a great question. So you don't need to save the predictions to the existing table. It has to go to the same database. But you may, for example, have your system of record that has a gold copy of the customer record. You might want to write that to a separate table just for data cleanliness reasons. So you can definitely set the SQL right to an insert statement and insert it to a new table.
Great. Okay, so our next question is, can I schedule this to run automatically?
Yeah, so when you see the command line that we have, the Java command line or the Python piece, what people do is they take that, as a script, and they put it into their scheduler, whether it's a cron scheduler in Linux, or there are several commercial, DevOps automation tools like Jenkins, for example. They can just take that script and execute it on whatever time schedule you need.
Awesome. The next one we have is, can it handle writing multiple predictions?
Yes. So you can write multiple predictions in either by leaving the SQL prediction statement in the configuration file blank, which means every prediction that comes back from the model will be written. So if you have, target.0, target.1, I've actually seen a customer that made 100 predictions per call. You can write all of them back, or you can actually pick which one you want to be written back, either way.
Great. We got a couple more here. How can the SQL be created to match the model?
Right. Yeah, so creating the SQL is the trickiest piece, right? Because you could have typos, you could have, you could mistype the name of the column, and it could be hard to figure out initially. So there's an option when we execute the Mojo to say inspect equals true, and that will auto-generate the SQL select and the SQL update statement. Then all you need to do is fill in a table name, because we can't figure out the table name from the model, but we know the feature names that we used to build the model in the first place. And so there's a pretty good likelihood that they match. Usually they would in the database unless they've been renamed, but usually they will match, and so that will auto-create those for you.
Great. Okay, the next question is referring to slide 17. So on slide 17, in the list of Java options, would it be beneficial to add XLP since you have a rather large 10 gigabyte heap, i.e. to use large pages for one's JVM heap?
So it kind of depends. It depends on the JVM that you're using and the underlying operating system. Large pages tend to be a little bit more wasteful. These are not typically long-running batch jobs. So the cost of the getting large pages is probably not worth it. There's a number of things that the Mojo has internally that helps it be efficient from a memory consumption point of view. So I don't think you'd actually get a lot out of it from a batch operation.
Okay. It's looking like we just have one more here. If you do have any other questions, please feel free to send them over. This is asking, where can we download this from?
All right. So, we have a number of things that we can do with, we're looking at adding it as part of a deployment option for driverless directly. In the meantime, people can contact us, and we'll walk through setting it up with them to make sure it's working for them. So just reach out to us, and we'll do that. I'm happy to do that, whatever someone needs.
Great. We got one more. Does your scorer run as a UDF, stored procedure, in a database or outside of a database? Right.
So the one we looked at is running outside of the database. Now, there are options for UDFs inside of databases that are built in Java. So, for example, Microsoft SQL 2019 has an embedded JVM. So the code could actually run directly on that JVM and then actually run directly inside of the instance. The reason that I didn't put this as a UDF in this particular case is that the ability to scale across multiple machines remotely seem to be the most exciting to a lot of our customers, because it allowed the data scientists to easily deploy models when they've trained them. When you put it into a UDF, it can be a little bit more of a DevOps, hands-on to deploy that. Having said that, we actually have UDF examples for things like Hive, where you take the Mojo, the same Mojo, and you can use that as a UDF in Hive, and then write SQL against that as a UDF, and that's a really powerful way. Databases have slightly different ways to implement them. Some have a JVM inside of it, like Microsoft SQL. Postgres, for example, has PL Java, which is a compiled Java, and so there's some things that make it a little bit more complex to do, but it's feasible if that was something someone really wanted to do.
Great. That about wraps it up for the questions that we had coming in. So we can go ahead and end the presentation here. I want to thank Eric for taking the time today and doing a great presentation. I'd like to say thank you to everyone who joined us today as well. The presentation slides and the recording will be made available on our Bright Talk channel. And have a great rest of your day.